Many of the products we use every day are produced from raw materials. Distillation is a process that's often used to turn raw materials into finished products. Because distillation is involved in the production of so many products, it's important for plant operators to understand how it works. Distillation is a process that uses heat to separate two or more substances in a liquid mixture. This is done by vaporizing one or more substances in the mixture and separately recovering the vaporized substance and the substance that's left over. To fully understand distillation, it's important to understand the physical principles that make the distillation process possible. The basic physical principle involved in the distillation process is changing states of matter. First, a substance in a liquid mixture is changed to a vapor. Then, to recover the separated substance, the vapor is changed back to a liquid. Matter normally exists in one of three different forms or states: as a solid, as a liquid, or as a gas or vapor. The term vapor is often used to identify a gas that's created by heating a liquid. Most substances can exist in all three states of matter. For example, we usually think of water as a liquid, but water can also exist as a solid, ice, or as a vapor, steam. All matter is composed of very small particles called molecules. These molecules are constantly in motion. The state of a substance depends on the speed at which its molecules are moving and the strength of the bonds between the molecules. One way to change the state of a substance is to apply heat to it. For example, when heat is applied to water, it speeds up molecular motion. As a result, the bonds holding the molecules to each other weaken, and the molecules are released as steam. Heat is applied during the distillation process to change a liquid substance to a vapor. Later, heat can be removed to change the vapor back to a liquid. Distillation involves changing matter from one state to another. Two of the factors that affect changes of state are heat and temperature. In this part, we're going to look at how heat and temperature affect the distillation process. Let's look at an example. When heat is applied to water, the water molecules move faster and the water's temperature increases. If we apply enough heat to raise the temperature to 212 degrees Fahrenheit, which is the boiling point of water at atmospheric pressure, bubbles of water vapor are formed. When these bubbles reach the surface of the liquid, they escape from the liquid as steam. Steam is a vapor. It's a gaseous form of water, which normally exists as a liquid. The process of turning a liquid into a vapor is called vaporization. In this illustration, we've added a dome to contain the vapors. When the temperature of a vapor is lowered, for instance by the cool air circulating around this tube, its molecules will move slower and closer together until it turns back into a liquid. When a vapor is cooled, it condenses into a liquid. This process is called condensation. Now, to raise the temperature of a substance, we apply heat. To lower the temperature of a substance, we remove heat. The heat that's associated with changes in temperature is called sensible heat. Changes in temperature can be measured by a thermometer. A thermometer can sense and measure temperature changes as sensible heat is applied or removed. The heat that's applied to water to raise its temperature to the boiling point is sensible heat. When heat is applied after the boiling point of a liquid is reached, the temperature of the liquid does not continue to increase. The heat that's applied after a liquid starts to boil is absorbed by the molecules as the substance passes from the liquid state to the vapor state. The heat associated with a change of state is called latent heat. Latent heat is observed as a change in state, not as a change in temperature. The term boiling point refers to the temperature at which a liquid boils at a given pressure. But in the context of distillation, there is more than one boiling point. That's because the liquid being distilled is a mixture of two or more liquids, each of which has a characteristic boiling point. Because each substance in a liquid mixture has its own boiling point, the mixture has a range of boiling points, which is known as the mixture's boiling range. The boiling point of the component in the mixture that boils at the lowest temperature is the mixture's initial boiling point, or IBP. The mixture's final boiling point, or FBP, is the temperature at which the component that has the highest boiling point boils. The final boiling point is also commonly referred to as the end point of the mixture. The end point is the end of the mixture's boiling range. One of the factors that affects the distillation process is pressure. One type of pressure is vapor pressure. Vapor pressure is the pressure exerted by vapor molecules that escape from the surface of a liquid. To get a better understanding of vapor pressure, let's look at an illustration of a closed container of liquid. In any liquid, some molecules escape the surface of the liquid as vapor, and some of the escaping vapor molecules return to the liquid. The escaping molecules create pressure by colliding with the container's walls. The more molecules that escape the liquid, the greater the pressure. Eventually, a point can be reached at which the number of molecules escaping from the liquid equals the number of molecules returning to the liquid. The pressure exerted by the escaping vapor molecules at this point is called the vapor pressure of the liquid. A liquid's vapor pressure indicates how rapidly the liquid will vaporize at a given temperature. For example, a low vapor pressure indicates that a liquid produces a small amount of vapor at a certain temperature. A liquid with a high vapor pressure has a low boiling point. Vaporization occurs at a low temperature, so the liquid does not require much heat to begin boiling. On the other hand, a liquid with a low vapor pressure has a high boiling point. Now, there are actually two types of pressure that are important to distillation. We just saw how vapor pressure affects the process. The other type of pressure is external pressure. External pressure is basically the pressure that a substance is exposed to. In an open container, the external pressure is the pressure exerted by the atmosphere. In a closed container, the substance is exposed to pressure inside the container. We'll use this open container of liquid to understand the relationship between vapor pressure and external pressure. With the container open, the liquid is exposed to atmospheric pressure. In order for vaporization to occur, the vapor pressure must overcome the external pressure that's acting on the surface of the liquid. One way to cause vaporization to occur is to increase the vapor pressure by heating the liquid to its boiling point. Another way is to decrease the external pressure. For example, if we close the container and draw the air out to reduce the pressure on the liquid will boil at a lower temperature. Less heat will be necessary to increase the vapor pressure enough to overcome the external pressure. On the other hand, if the external pressure is increased, the temperature required to boil the liquid will also increase. If the pressure is increased, for instance, by 100 pounds per square inch, the boiling temperature will increase. In this case, the water will not boil until its temperature reaches 338 degrees Fahrenheit. The higher temperature is necessary to give the liquid molecules sufficient energy to overcome the increased pressure on the liquid. Now, because a liquid that's being distilled is a mixture of two or more liquids, the term partial pressure is used to refer to the vapor pressure of an individual component in the mixture. The sum of the partial pressures of all the components equals the mixture's total vapor pressure. One additional term that's important to a discussion of the distillation process is relative volatility. Relative volatility is the relationship between components in a liquid mixture as determined by their boiling points. Let's look at two examples. Pentane boils at approximately 96 degrees Fahrenheit at atmospheric pressure. Suppose pentane is one of the components in a liquid mixture to be distilled. The other component is heptane, which boils at approximately 209 degrees Fahrenheit at atmospheric pressure. The boiling points of the two components are relatively far apart. This mixture has a high relative volatility. It would be fairly easy to separate the two components using distillation. Now let's examine a liquid mixture of butane and isobutane. At atmospheric pressure, butane boils at approximately 31 degrees Fahrenheit. Isobutane boils at approximately 11 degrees Fahrenheit at atmospheric pressure. This mixture has a low relative volatility. A low relative volatility means that the components are relatively hard to separate by distillation because their boiling points are close to each other. Well, we've covered a lot of information in this topic. We saw how changes in the state of matter relate to the distillation process, and we saw how temperature and pressure affect aspects of the distillation process. Now try a few practice questions to check your understanding. The basic physical principle involved in the distillation process is changing states of matter. First, a substance in a liquid mixture is changed to a vapor. Then, to recover the separated substance, the vapor is changed back to a liquid. The boiling point of the component in the mixture that boils at the lowest temperature is the mixture's initial boiling point, or IBP. The mixture's final boiling point, or FBP, is the temperature at which the component that has the highest boiling point boils. The final boiling point is also commonly referred to as the end point of the mixture. The end point is the end of the mixture's boiling range. Relative volatility is the relationship between components in a liquid mixture as determined by their boiling points. Let's look at two examples. Pentane boils at approximately 96 degrees Fahrenheit at atmospheric pressure. Suppose pentane is one of the components in a liquid mixture to be distilled. The other component is heptane, which boils at approximately 209 degrees Fahrenheit at atmospheric pressure. The boiling points of the two components are relatively far apart. This mixture has a high relative volatility. It would be fairly easy to separate the two components using distillation. Now let's examine a liquid mixture of butane and isobutane. At atmospheric pressure, butane boils at approximately 31 degrees Fahrenheit. Isobutane boils at approximately 11 degrees Fahrenheit at atmospheric pressure. This mixture has a low relative volatility. A low relative volatility means that the components are relatively hard to separate by distillation because their boiling points are close to each other.